Okay, thank you.
Good morning, friends. I'm Ramamurthy. This is the opening interface of Quantum JS. So first we'll open the Georeferencer. Georeferencer is a plugin, and if it is not available, you can get it from plugins. If it is already available, then this is a Georeferencer tool. Okay, and this is a submodule within the Quantum JS. Now you can add image, the image which you want to georeference. So this is I have taken it from Google Earth. The same area Sinha was showing. So here this is not reference to the Earth surface. It's not a georeference. So we need to have some control points, ground control points, to georeference this particular image. And for that we have taken some points like in the northwest 1 point, northeast 1 point, and southeast 1 point, and southwest 1 point. So you can take any number of points and from anywhere. Only thing is the spread should be all over the map. So you cannot take just 4 points in one northeast corner. So in that case, georeferencing will not be accurate. So I have taken 4 points. Now yeah, see these are the control point windows, the tools. So you can add control points here. I'll zoom it. So this is one control point here, and add one control point here. So this is the point for which I am entering real world coordinates in terms of degree minute seconds. Here are degree minute seconds are a decimal degree. So I am giving the decimal degree. Easting is longitude. For this 78.466, and northing is 17.436. Yeah, now full window, and go to the next point. This is another junction. Add one more point here, and here the second point is coordinates are 78.487, 17.428. Sinha sir? Hello. Yeah. Next is third point. I'm taking third point in the southeastern part. The third point is 78.412, 478, and northing is 17 point. Northing is latitude 412, and similarly, you can add one more point here. Point 478, 17.412. So after adding 4 points, just you can run this start georeferencing. But before that, you have to give the settings. Settings is a reference system you have to define, because we are replacing screen coordinates with real world coordinates, like 78.478 or 17 point something like that. But what are those things we have to specify? So that is being defined in your target SRS, Spatial Reference System. So this is a geographic coordinate system. That is a three-dimensional coordinate system, angular coordinate system. That's why we are giving in a decimal degree, and the datum is WSC 84. So after defining this and say OK, then start georeferencing. So once now it is georeferenced. Adding control points is one. That's the important thing. And the second step is defining the settings. After that, run the georeferencer. So once this is done, your image is georeferenced. Now I'll open the georeferenced raster image here. So sorry. Yeah, this is the. Yeah, just notice in the coordinate part. Earlier, I was not getting these coordinates, but once it is georeferenced, as I move any place, any part of the image, I am getting the real coordinates in terms of decimal degree. So you can change it also, degree minute seconds also, but for display purpose. So now this is a georeferenced base map for extracting the features. See, this is a map. This is an image. So you have several features. You have a lake, you have road, you have railway network, settlements, all those things. But we are interested in roads, lake, and some tourist points. So one is a point feature, another is a line feature, another is a polygon feature. So having done this georeferencing, next step is creation of the layers. Vector layers. This is a raster part. This is a raster part georeferenced image. So this will be your base map for extracting the features. Now next create layers. Create a shapefile. You give the shapefile name. Some name you give point shapefile. So you have to define the geometry. So basically there are three geometries. One is the point geometry, another is line geometry, another is polygon geometry. So first I am taking the point geometry because I will be digitizing, extracting the features of a point nature, that maybe a tourist spots, etc. So select point, and the coordinate system it is taken from the base map. Since base map is open, it's taking the same coordinate system, and it has to be same coordinate system from which you are extracting the features. Now, when we create a shapefile vector layer, automatically, see there are two parts. One is the geometric part, another is the attribute information. So automatically, and one column is created by the system, that is ID. So if you want to add one more column, some more information columns, so then name, just name. Then this is a 50 characters and add to the field list. Okay, okay. Now see, the point layer is created, but nothing is in this. So now we have to digitize the features, extract features from the base map. So this is a point shape, and enable editing. This is a toggle editing button. So people who are working with RJS, it's very much similar to that. So you enable the editing, and since it's a point related tools are highlighted here. So I'll take this is add point feature. Hold your cursor on any tool, it will explain what the tool is. So add point feature. and go to point of your interest. So this is a one tourist spot that is in the middle of the Hussain Sagar Lake. There is a statue called Buddha, Lord Buddha. So that is one of the tourist points in Hyderabad. So I'll digitize that particular point here. Okay. Now ID is 1 and
अभी लाइव स्ट्रीमिंग है ऑन है.
pardon? Yeah. So here name of the place is statue of Lord. Done. Now see. So there is a point created. Now you can see the attribute information also. Right click and go to the open attribute table. Yeah, open attribute table. So while creating the point shapefile, we have created ID and name. These are the column names. And after that, while digitizing features, we have digitized one particular feature. That is ID number. We are given an attribute information as 1, and under name it is statue of Lord Buddha. So this is how you generate point feature data. Now you can save it. You can save layer edits and stop. Next part is next layer is go to layer, create layer, one more layer. Now it is line. So lines are roads. I'm creating another layer, thematic layer. The layer name is theme name is road, and geometry is line. And the spatial reference system, it's same thing. That is 4326 geographic coordinate system with the WC84 datum. And again the road name of the road. That is a column name. And this is 50 character length, the length of the field, and add to the list and say OK. Now there are some couple of roads for demonstration. I'll digitize these roads. Again, select the layer which you want to edit, that is a road, and after that enable editing. And here tool is now different. So earlier it was a point, now add a line feature. So I'll just digitize some lines here. Right click at the end of it, so you will get that is the end of the digitation of that particular line. And one here it is, the road name is Tankman Road. The road name is Tankman Road, and say OK. So add one more. Some couple of roads for demonstration. I'll digitize these roads. Again, select the layer which you want to edit, that is a road. And after that, enable editing. And here tool is now different. So earlier it was a point, now add a line feature. Second layer is over, and next we'll take a polygon. Again, same procedure: create layer, shapefile, and here file name is lake, and the geometry is a polygon type. And special reference system, same special reference system, and name of the lake. And the character length is 50. Then add to the list and say OK. So now again go to the lake and enable editing, and the feature is it's here different. Let's say add polygon, and now the same thing. It's not very accurate for demonstration purpose. I am doing it. So while you do it, you can do it very accurately in your real-time projects or for practice also. Zoom it and do it very accurately, because it matters a lot, because depending upon your accuracy of the digitation, the area, just distance some lines here. Area also get changed. Done. This is
In
one.
in and zoom out condition, how to handle the digitization tools.
Okay. Lake. Right click at the end of it, so you will get. Now see, so we are. That's the end of the distribution of that particular line and one. But you are not able to see road and points, because polygon is on the top of it. So you just bring down here. So always if multiple layers are there, polygon is the field. If it is filled with, here it is the road name is tangent road. You will not be able to see lines and points. So you can display the colors. The road name is Tankman Road, and say OK. So add one more. I'll go to label. I'll label it single label and name and say apply. Some public roads for demonstration. I'll distance these roads. Again, so here also I'll label all the features and say apply. So Sinsagar Lake and point shape file. Again go to labels and single label. And here you have to give the field name, which field you want to label it. So we have two columns. One is ID and name. So in all the layers we are. The layer which you want to edit, that is a road. So one is the point feature, another is the line feature. This is the road feature. Road, we can increase the thickness of the road. And after that, enable editing. Symbology, go to here, you make it as 2. So one road feature, another one is a point feature, and third is a polygon feature. You have 3 themes. One is point theme, that is point of tourism important. And here road is no different. Second is line, that is road. Road is represented as a line, and lakes are represented as polygon. So this is in nutshell. You can practice and digitize several roads around the lake and some other points also. So thank you very much. Any queries, any doubts? I think we'll discuss in the evening in team here, or even now also. If you have any doubts, please send it through WhatsApp or YouTube live chat. Thank you very much.
Hello, Murthy sir.
Please.
Murthy sir.
Yeah, you can supplement. You can add Sinha sir if anything is to be added. I think for the benefit of
Area and line length.
those things. Okay. Yeah. Lake, I think if you want to calculate the area, one thing is automatic. There are two ways of measuring the length and areas. One is manually, another is automated. Suppose here is a lake, there is a tool here, measure area. So just distance, take this area. Approximately, I'm doing it. So to the left of there is a window. Here it is 81,902 square meters. And if you want to see it, yeah, in acres, you can do it in acres also. This is approximately I'm doing it. Please bear with me. So around 1,000 acres. This is one way of doing it. Another is automatically it generates. Similarly, for length of the road, measure line. Suppose you want to measure the length of this Tangman road from one end to other end. See, this is roughly around 2.472 kilometers. The length of the Tangman. So you can calculate, you can measure the distance and area using this tool. And there is another tool automatically it generates. I think go to vector, check geometry. Yeah, add geometry attributes. No, it's not that. Yeah, you can open the attribute table and yeah, attribute table, open attribute table. And here I think you can calculate areas and yeah, geometry. So this way also, so there are several things here. You can calculate areas and lengths using this tool also, geometry, under geometry. So you open attribute table, and after that go to the your functional editor, and there are several options under geometry. You can calculate the area, those things, and that will be added and as extra attribute, extra column here after ID, name, and area also. Okay, Sinha, is it okay?
Right click the layer and there will be a calculator will be there. Right click, yeah, attribute table.
Yeah, this is the calculate geometry and area, and yeah, field is but you have to
No, no. Here, tool for calculating the area is not there. Toolbar of the attribute table. Do you don't have a calculator?
No, prior to that, I think you have to create a field.
No, the calculator ask
you can add one more field to this. Add field.
Calculator right side. Yeah, right side. Calculator is there.
Just a minute, sir. Add field area. And here instead of whole number, you take decimal and say OK. Then close. So now see, while creating the shapefile, we have this is a system generated column. We have added name, but subsequent to that, based on the requirement, we have added one more field, that is area, which is this is a, it's not integer, it's a double. Now you can go to calculate geometry. So area is to be calculated. Then your field is so after calculating the area, it will be added to the attribute table. So you select whether it is to be in square meters or square kilometers or square yards. So I am taking as square meters because the polygon is a area field, so it is in square meters, and say OK. Open attribute table. Now area is calculated automatically. So, but it is not dynamic. Only thing is, if you modify the geometry and again you have to recalculate the area. It is not dynamic. Suppose for some reasons you want to edit lake boundary, then area will be decreasing or increasing. In that case, you have to again recalculate, and the revised area will be populated in the area field. So you have to remember that it is not dynamically changed. So similarly, you can calculate
length value.
So length is for roads. Same thing. Right click, open attribute table, add field, add a new field. Here it is length of the field, length, and this is a decimal, and say OK. Then right click, calculate geometry. So here length, and field is length field, and say in meters. Say OK. Now go to the attribute table. 2.5 to 2.517 meters. So that is the beauty of GIS. So once your image is georeferenced properly and features are digitized accurately, then area and perimeter or length will be calculated very accurately. So it all depends on the accuracy of your georeferencing, accuracy of digitization. The way I digitize, it's only very randomly digitized. It's not very accurate. The area may be proportionately it will be erroneous. So kindly remember, first is the collection of the selecting the ground control points. That is very important, and georeferencing. Second point. Then while digitizing, it has to be very accurate, and zoom it and digitize it. So once that is done, then the areas and lengths will be calculated accurately. Thank you. So that is, I think, end of today's session. And if Sinha sir wants to. That is, I think, end of today's session. And
all things are covered here, sir. And this is
that is, I think,
end of today's session, and all things will be told here, sir.
And let them walk over this exercise. Whatever questions are there, they put on our WhatsApp account, or stream will be closed.
Hello, Ramamurthy garu. Please listen to me. Ramamurthy garu.
Please, I am listening, sir.
You see your WhatsApp. Professor Pratap has asked a question. He wants to know how to add the plugin of Google Maps.
Google Map. Okay, I just explained. So there is a tab called menu. Under web menu, open layers plugin. If it is not there, you can just go to plugins and manage plugins. So this is very important to know. There are installed plugins. There are not installed. Now, if it is not there, then type it open layers plugin. If it is not installed, you can just select and install it. But in my case, it is already installed. So close it. Go to the web and open layers. There are several options. So you can open Google Maps and Google Physical Maps, Street Maps, Hybrid Maps, Satellite Maps, and similarly open Street Maps and Bing Maps and Apple Maps. So Wikipedia Maps also. So now for the verifying the accuracy of your georeferencing, you can open Google Maps and Google Satellite Maps. Now Google Satellite Maps, bring it down, and this is our image. You see. So your georeferencing is not very accurate, but it's okay. It's superimposing on the Google Map satellite image. Is it okay, Professor Pratap? I think. Similarly, if you want open street maps, you can open street map also. You can open. This is open street maps. So is it okay, sir?
Murthy garu, Sonal Dash has one question for georeferencing an image. We have a prior knowledge of 4-point coordinates.
Yeah.
Means he wants to know whether the coordinates are known.
Yes. So, I'll answer. So, Sonalji, actually, if there is a topo sheet sort of thing or map is there with some corner coordinates, then you can take the corner coordinates. In this case, this map without any corner coordinates. So you have to identify some ground control points and take XY coordinates, that is longitude, latitude. And with those coordinates, you have to georeference it. So one way is you go to, now if it is in the field, you go to a particular point where you can identify that particular feature on the map. Go to that particular point and take the GPS readings. That is one way. Or you can identify those points on Google Map or Google Earth or OpenStreetMaps. You identify that particular point location, and you will get the XY coordinates. With those XY coordinates, you can georeference it. So one way is you should have ground control points to georeference. The real coordinates of the map, at least 4 points, and spread over the entire map. It is not that it will take 4 or 8 GCPs at particular point. So your georeference will be erroneous. So ideally, it should be spread over the entire map. and at least 4 more points is more accuracy. But only thing is more points with accurate points, that will be more accuracy.
Sir, one more question has come. Manoj P.
Bull.
Hello.
Yes,
He
sir.
wants to know. Okay. He wants to know how to find GCP point without ground observation.
That's what I told you. So see, if it is if you are in the ground, you can go to that particular point, the point where you can identify on the map, then take GPS readings. That is one way. If it is not there, same thing. If you can identify the same point on a Google Map or Google Earth or OpenStreetMaps, so take XY coordinates. See, if you can take XY coordinates from the OpenStreetMaps also. Just go to take your cursor there and just click it. You will get XY coordinates.
Now another question has come up. Nishant Khokhar ask how to find latitude and longitude of a ground reference point exact.
Exact. That's what. Already. So it's only either you go to that particular location in the field physically and take XY coordinates with your GPS, handheld GPS or your mobile. That is one way. Second is you can identify that particular point on OpenStreetMap. You can take the cursor to that particular point. You'll get XY coordinates. So your georeferencing, proper accurate georeferencing will depend on the accurate GCPs. Yes, Sinha sir.
Now Ritesh Arya has one question.
Sir.
Can you just summarize the steps before closing?
Yeah.
He wants some summary of the session.
Aryaji, so now I'll summarize. First, I have a base map without any coordinates. Base map, a satellite image, just cropped satellite image base map of without any coordinates of Hyderabad, that Hussain Sagar area lake. And what I did, so I identified some points, maybe road junctions or some accurate points where I can go and collect GCPs. So I have identified 4 such points. Of roads or intersection of drainage, that will be ideal locations. So I have taken 4 GCP ground control points and taken XY coordinates from OpenStreetMap or Google Maps. So I have collected XY coordinates, that is longitude, latitude of 4 control points which are placed on my image. And opened Quantum QGIS, and QGIS there is a module called Georeferencer. You activate that GCP, Georeferencer module, and open this particular image in the Georeferencer and add control points, 4 control points which I marked on the image, and replace those coordinates with the real world coordinates.
Ramamurthy garu,
Sir,
please bring your raster which you georeferenced again, and just for showing again, georeference just once more. Line, point, polygon, they know it, I think.
Okay, georeferencing. Right, I'll do it, sir. So this is the plugin Georeferencer, and add your image. Please notice, Mr. Arya, in the lower right, this part, 671630. When I move the cursor, this is giving my screen coordinates, not the real world coordinates. Done. Now I identify some particular points, 4 points. Yeah, this is 1 point. So this is adding the ground control point, GCPs. Now I am replacing, just a minute. So what is the coordinate here? 143.4, comma, minus 37.4. So you just notice this point, particular location, point. For this particular point, the screen coordinates are 142.1 minus 38.0. This I am replacing with 78.466, that is longitude, and 17.436.
These are degree decimal values.
Decimal degree, yeah. And go to another point. This is my, I think probably I have taken this second point here. I had control point here. Second point is, I think 78 point. Now replace the second point with 78.487, and northing is 17.428. These coordinates I have identified from the Google map. You can do it from the OpenStreetMap also. And the third point is somewhere here, I think. Yeah, no, this is the fourth point. The third point is, I think, somewhere here. This is 78.478, 17.412. And the fourth point is here. This is a road junction. This is 78.465, 78.465, and nothing is 17.414. So I given 4 control points. One is in the northwestern part, another is the northeastern part, another is the southeastern part, and the other is the southwestern part. So fairly spread is good enough for this type of map. So you can have a number of points, one more point here, or one more point here, or one more point here. So number of points, I think more number of points, but only thing is accurate points. More number of accurate points is necessary. So you have one more point here also. So having done this, adding the control point GCPs, next is go to the settings. See, we have replaced screen coordinates with some numbers like 78.467, 17 point something like that. But the system should understand that the numbers given are decimal degree. Those things you have to define in the settings. So here that will be defined here. So this is a geographic coordinate system, degree minute second with degree minute seconds, and datum is WC84. So if it is not defined, you define it, and then after that say okay. Then run the georeferencer. So automatically, what exactly does is, so everything, each and every cell of this your raster image will be resampled to the new location, new boundary. the change coordinate system. So that's why the accuracy of the control points is very important. So once after adding these points, you can setting up the this coordinate system, etc. You can just run it. This is georeferencer. So am I clear? Can close the georeferencer. One more point here, you can add the points also. You can save these points in a text file also. Save control points to space. You can save it. Saving is necessary. Suppose something went wrong, and if you want to again redo it, all this exercise is not necessary. Just load those control points automatically. It will be added to your georeference.
What is the look of that file, please, if possible? That notepad file.
Notepad, I think we can open it and you can see the file is saved in
and
this particular points you can open in a notepad. This text file you can open and see it.
Yeah, what are the things are there that you want to show the trainees?
I think if no more questions are there, Sinha Sahab and we can close this session at 5 p.m. Anyway, we have the team viewer session.
Yes, sir. I think the rest of the things there.
Yeah. Close the lives. You both have done wonderfully well. It has really come out well. So,
sorry that my slides were could not be streamed.
Don't worry, Sinha.